right? Just like in Monopoly, those taxes were the price was sort of like 1 over the elasticity, or some version of it is. Here too, the tax is just some very simple transformation of the elasticity, and then there's this thing which is how much welfare weight you put on the consumers, how much of the consumer surplus you internalize. So if sigma is very large, right? If there's lots of inequality, we're going to want taxes near 1. If there's no elasticity, if there's no deadweight loss associated with taxation, we're also going to want taxes to be near 1. And on the other hand, if it's very inefficient, or if we have a very equal society, then we're going to want very low taxes. Yeah.
Sorry, for the first equation,
yeah,
the one that's wrong.
Yeah.
You want the derivative of total welfare to be 0, right?
Yes. Sorry. So we had this derivative of total welfare we derived, and we set that equal to 0, and that's how we solved it. Okay. So that model covers sort of the average tax rate that we want to charge to most Americans. But Obama has recently proposed charging like an extra surcharge on the super rich, right? And when we think about taxing the rich, if we follow the log utility specification, the welfare of rich people doesn't really matter very much to us, or at least the value of a marginal dollar, because if people are earning over $1 million, then their welfare weight is about 1/20th of what a typical American is earning, or a typical welfare weight on the American, right? And so, just to simplify things, to make this exactly like a monopoly problem, let's just think about what tax we could charge to rich people to maximize the total revenue we get that we can then redistribute, right? So it's just a normal trade-off. If we tax more, people will work less, so we'll earn less revenue. On the other hand, if we tax more, we're just going to mechanically earn more money off of it that we can distribute. Okay, so suppose we now raise the tax, or potentially lower the tax, depending on what's optimal, on people who are earning over $1 million, right? And let's call that T sub 10 to the 6th, right? And let's let the average income of people who are earning more than $1 million be I bar sub 10 to the 6th. Now, there are 2 effects which correspond exactly to the 2 effects in the monopoly problem. And Xiaoling, could you explain what those 2 effects are?
Can you repeat the question?
So there's 2 effects when we increase the tax on the super rich. What are those 2 effects on the amount of revenue that we raise? They correspond exactly to the 2 effects in the monopoly problem. What?
The revenue increases.
Yeah, and what's the second effect?
Their income falls.
Yeah, and that's going to reduce the amount of revenue you're earning, right? So it's just like in the monopoly problem. When you raise the price, you directly get more money, but on the other hand, you reduce the quantity that people are purchasing, right? And so that's going to reduce the amount of money you get, right? So the first one is called the mechanical increase. And that's just, for every person I who's earning above $1 million, you're going to get an additional amount, I minus $1 million, right? On the other hand, they're going to reduce their income, on average, by the income times the average elasticity of people at that income times 1 minus the tax rate. And so that reduces the amount of tax revenue that we earn on them by the tax revenue we're currently earning on that income times the amount they reduce it for 1 minus the tax rate. Yeah?
Why does revenue increase by
Because we're charging a surcharge on all income above $1 million, right? This is what Obama's proposed, right?
So
He
you're
said,
just taking everything after 1 million?
yeah, exactly. So this is like a special marginal tax rate for everyone above $1 million, earning above $1 million. This is what Obama has proposed recently.
So why isn't that
What do
multiplied by
you
the
mean,
tax
like,
rate?
if I'm making 1.5 million, then you're taking $500,000 away?
Taking some part of $500,000 away. So there's like a new tax rate, T times 10 to the negative 6 times that last $500,000 that you're making.
So it would be
Then I minus, you just wrote I minus 1.
Yeah, so if you're earning 1.5 million minus that, then if we raise this tax, how much does that increase the revenue we earn off of you? It increases it by the change in tax times your income minus 10 to the minus a million, right? So if someone's earning $1.5 million, how much do we get if we raise from 50% to 51% the tax rate that we charge them on incomes above it? They get 0.01 times $500,000, right? Yeah. Tejas, do you have a question?
No, I was just wondering, like, why wouldn't you multiply it by the tax rate?
Yeah, he's doing the
Did I
derivative.
get it? Yeah.
Yeah. What?
I think I get it now.
Okay. So, the total impact this has on our revenues, right, is, so this term and this term are both multiplied by I, so we can factor out an I. So we get 1 minus t sub 10 to the 6th times the average elasticity over 1 minus 10 to the 6th minus 10 to the 6th, which comes out of this part, right? This is exactly the monopoly thing, right? This is the gain that we get by raising the price. This is the loss that we get by having to change, by reducing the quantity. And then we, the optimal tax is going to equate this to 0 on average for people who are earning above $1 million, right? So the average marginal revenue we get out of all those people has to be equal to 0, right? And this is exactly what Sayez's famous formula does. So if we just take the averages of all that stuff, the income becomes the average income of people above $1 million, and the elasticity becomes the average income-weighted elasticity of people earning above $1 million, right? Okay. Now let's let alpha be the average income of people above $1 million divided by that average income minus $1 million. And then by the same logic we did before, we're going to get another formula, and see meow. Could you come up or do on your pad or sort of explain to us what the formula we get is?
What are we trying to
So we're setting this equal to 0, right? This is the average marginal revenue that we get, and we want to set that equal to 0.
come on and do it?
Yeah, sure. And hint, you want to use this definition of alpha. It'll make things simpler.
Okay.
There's a eraser there, and there's some chart.
So I want to set that equal to 0.
The calculation is sort of already up there.
Yeah.
You should have erased it. No, erase it again and do it again. Hold on. It's sort of like when you go to detention, right? You erase it and you just write it over again a million times. Yeah, you want to solve out for t sub 10 to the 6th.
Okay.
Yeah? There's a 1 minus. So first figure out how you can get alpha out of that, because that'll make your life
Yeah, I
more
was just
easier.
trying to figure out.
Yeah, you should be taking the right way.
Okay, so what's the number?
Yeah. That's right.
And then
To get alpha, you're going to need to divide through by I bar sub 10 to the 6th, right?
this.
Yeah. And then what does the left-hand side become?
All that.
Exactly.
And then goes, this T then.
Yeah.
Oh, okay. Okay, so this one.
Yeah, you should get all the t terms on one side and then factor out the t and divide.
This is really-
Basically got it.
Yeah, and then like subfactor out. That's what it is.
Yeah.
And then just,
Yep.
over.
And then here's the formula. Yep. Great. So the formula is 1 over alpha. Very well done. 1 over alpha over 1 over alpha plus the average elasticity is the formula. And notice that that's almost exactly what we had before, right? The only difference is before we had sigma rather than 1 over alpha, right? And that's actually really nice because, as we're going to see in a moment, alpha is like a really natural measure of the inequality at the very top part of the distribution. Because it says what is, the average, 1 over alpha is the average amount that people earn above $1 million minus $1 million over the average amount that they earn. So that's like, imagine that the average person who's earning over $1 million is actually earning $20 million. Well, then this is going to be really close to 1, right? On the other hand, if they're earning very close to $1 million and there's not much inequality at the top end of the distribution, right? Then this is going to be very close to 0, 1 over alpha. Okay, so this again exactly captures the equity efficiency trade-off. As we get more inequality at the top part of the distribution, right? These 1 over alpha is going to get large, and that's going to lead us to charge a very high tax rate. As the elasticity gets large, that's going to have us charge a lower tax rate. And so what that means is that taxes should be progressive if this inequality at the top part of the distribution is greater than the overall inequality. If 1 over alpha is greater than sigma, and it should be more progressive if the rich have a lower average elasticity of labor supply than does the average American, right? On the other hand, if there's less inequality at the top than there is in the middle, then you want to have a lower tax rate actually for the rich, a regressive tax. And if the average elasticity of their labor supply is higher, then you want to have a regressive tax. So now I want to try to get a sense for alpha and sigma. Yeah?
Is that optimum tax rate for sigma like for the lower before the surcharge?
Yeah, so that's like, imagine we have like a basic tax rate and then the rich pay a different tax rate on all their income above 10 to the 6th, above $1 million. And that could be a higher tax rate or in principle a lower tax rate if the Republicans get their way.
Okay.
To calculate sigma, one useful approximation is to assume a log logistic distribution. This is very similar to a log normal distribution. And just as you could have looked up on your problem set, you can look up online that the beta coefficient in this thing is just 1 over the Gini coefficient. And the mean of this is given by this formula. The mean of the US income distribution is about $46,000. That gives us alpha about 32,000. And then we can just throw this into Mathematica, and it shows us that as we